Alright guys, welcome to this page of the notes, and what we're doing is we're talking about that first objective where we're looking at solving equations that contain radicals. And what we've seen so far is that in order to solve these equations, once we kind of get that radical isolated on one side of the equation, we just raise both sides to the same power as that of the index. So let's keep going and try a couple more of these. Right away, the first thing I notice is, wait a second, I don't have a radical. Oh no, that's right. A rational exponent can be rewritten as a radical. I have a fractional exponent of 1/3, which we know is actually a cubed root. So let's rewrite it as a radical. And I have 3 times the cubed root of 5n minus 1 minus 2 is equal to 0. So absolutely watch out for that. I'll definitely do that to you thanks to what we just did back in section 6. We know that rational exponents, fractional exponents, can be rewritten as radicals. So there's my radical, and now what we'll need to do is solve this equation. Well, before I go ahead and take care of the radical, I need to get it by itself. I need to isolate the radical, which means get rid of the rest of the stuff. We'll start by moving this -2, and we can do that by adding 2 to both sides of the equation. That's going to leave me with 3 times the cubed root of 5n minus 1, which will all be equal to 2. Then I'll need to get rid of the 3. Since it's multiplication right there, we'll divide both sides by 3, which will leave me with the cubed root of 5n minus 1 equal to 2/3. Okay, great. Well, now what has happened is I have my radical isolated on the left-hand side of the equal sign. We just talked about the fact that in order to get rid of the radical, you have to raise it to the same power that matches the index. My index is a 3, so we're going to cube both sides of this equation. And again, I cube both sides because algebra says whatever you do to one side, you got to do to both sides. The index and the power are the same. They cancel each other out. And I'm left with 5n minus 1 is equal to. Now, property of exponents says whenever you have a quotient raised to a power, you just raise everything inside the parentheses to that power. A 2 cubed is going to be an 8. A 3 cubed is 27. All right, well, I got to get the n by itself, right? I'm trying to solve for n, so I need to isolate the n. That means add a 1 to both sides. So we'll add 1, add 1. That leaves me with 5n is equal to 8/27 plus 1. Now, you could certainly just do that on your calculator if you've got a calculator with you. I don't have a calculator with me, so in order to add these guys, I need a common denominator. My common denominator is going to be a 27. So I get a 27 in the bottom. But in order to put a 27 in the bottom, I also have to multiply the top by 27. Fortunately, the top is a 1, and 1 times 27 would just be 27. I can now add these fractions together because I have a common denominator. My common denominator is 27. And 8 plus 27, I believe, is 35. Okay, now, to get the n by itself, it's multiplied by 5, so I'll need to divide by 5. I have n is equal to 35/27, all divided by 5. This is a mixed fraction. Sorry, let me slide up. Which means that all you need to do, well, you could do a couple of things. You could either do keep it, change it, flip it, keep it, change the division to multiplication, and flip the bottom. 5/1 would become 1/5. Or you could just recognize in this mixed fraction, the 27 drops into the bottom, and you'd have 5 times 27. In any case, the whole thing is going to wind up reducing to 7/27. Now, what I need to do, right, is double check my answer. So please go ahead, take a second, double check it. What you'll find is that, yes, it does check out when you plug a 7/27 into the original problem. Both sides of the equation will be equal to each other, and that is actually a solution. Let's try another one. I got another one for you here on this page of the notes, and again, I've done the same thing to you. I've given you a rational exponent. but we know rational exponents are really just radicals in disguise. And so, because my denominator is a 4, the index will be a 4. So I'm going to take a fourth root of 2y plus 6. It's all minus 2, right? Minus 2, and that's equal to 0. Well, the first thing I need to do is get that radical by itself. So we'll add 2 to both sides. So we'll have a fourth root of 2y plus 6 is equal to 2. But to get rid of the fourth root, we'll raise both sides to the fourth power so that the power and the index are the same. They'll cancel each other out. 2y plus 6 is equal to 2 to the fourth power is simply a 16. Subtract 6 from both sides, I'll get 2y is equal to 10. Divide both sides by 2. Let me slide up just a smidge. Y is going to be equal, 10 divided by 2 is going to be a 5. Again, go ahead, take that 5, plug it in for y, check your solution, and it'll check out. Y equals 5 is a solution. Both sides will be equal. This will turn out, when you plug in a 5, this will turn out to be 0. And of course, 0 is equal to 0. All right, guys, that takes care of the first objective in this set of notes. We're solving equations that have radicals in them. And essentially, here's what it boils down to. You need to isolate the radical. And once you've isolated the radical on one side of the equation, right, you just raise both sides of the equation to the same power as the index. Whatever the index is, you'll raise both sides to that power. That'll eliminate the radical, and then you'll solve the equation like you would any algebraic equation. Don't forget to check your solutions. Now, head on over to the next page of the notes. We'll look at the second objective, which is solving radical inequalities, and we'll show you how to do that. I'll meet you guys over there.